Here you can see a model of a wind power plant invention based on our two recent US patents. This power plant can comprise of one or many modules, positions one on top of each other, so that they do not occupy a large area of land and take advantage of stronger wind at higher elevation. Each rotor has two discs. They're connected by an even number of well-balanced blades rotating around its central axis. The central shaft, or in some cases, two half shafts with low friction radial bearings, can be affixed to the center of the disc to provide rotation. Permanent or electrically induced magnets can be attached to the disc to produce electrical current in the coils located on the stationary structures. Electrical current can also be created by conventional generators connected with the central or half shafts at both sides of the rotor. The wind tunnel is of a rectangular parallelogram shape, with one side open for the wind's entrance and the other its exit. The large entrance is gradually narrowed down at the middle section and then quickly increase in height to the exit to create a natural Venturi effect. The rotor is placed at the narrow middle sections where the wind can only impact the plates on one side of its axis of rotation, thereby creating a positive momentum. The plates on the other side of the axis of rotations are covered within the tunnel to shield them from the wind. Our rotor has a large number of smaller blades than that of a typical propeller type, creating smaller centrifugal force and higher rotational speed, thus eliminating the phenomenon often referred to as helicopter thumping noise. Our setup will therefore guarantee that the rotor will rotate under the slightest of wind, provide complete transformation of available wind power. Propeller type, on the other hand, where the wind is pushing against its longer blades perpendicularly, will have more friction in its bearings and thus losing valuable energy. A shield controlled by a servo motor can change the speed of the rotor or shuts it down completely for maintenance. Each module can be placed directly on top of one another. So the whole structures can be positioned as one unit toward the wind. Another concept has been placed between decks of a parking garage type structures, which can be built as tall as a skyscraper to take advantage of stronger wind at higher elevation. The decks are open from all sides, and the modules can be oriented toward the wind autonomously. This power plant can be built as high as the technologies and material strength will allow, so that there is very little area of land being occupied. Plus, the higher the rotors are placed, the more energy they will produce. In contrast, the propeller type cannot be placed on top of one another. Thus it will occupy more land to create a comparable amount of energy. Energy output is also much better in our design. Wind speed in the lower part of our module tunnel would be higher than at the entrance, corresponding to the ratio of contractions. If the height at the entrance is 2 to 3 times that of the middle sections, the speed of the wind impacting the rotor's blades will be 2 to 3 times higher, and subsequently, the power of the rotor would be 8 to 27 times larger than that of a rotor placed in the ambient. This means that our power plant can replace between 8 to 27 propeller-type turbines of the same size, occupy a smaller area of land, and work with almost any wind conditions, which a typical propeller-type turbine will need wind speed of at least 10 to 15 miles per hour for it to work. Another advantage of our design is that the rotor can work horizontally, vertically, or even upside down. Here you can see a small wind generator with vertical axis of rotation, a wind booster to provide energy for a house. Or a boat. It can be painted with national flag for decoration. A larger power plant provides energy for a shopping mall. Here you can see a high skyscraper type power plant having a number of rotors placed one above each other inside a parking garage style structures open to the wind from every direction. A cross-section of the skyscraper shows each module is placed on each floor of the structure. The upper level, where the wind is strongest, can have 2 rotors. We hope that you enjoy our presentation.